This problem is on electronic homework number 23 for section 1.5 transformation. So I'm just going to go through it quickly, but one thing you might want to do first is set up what your parent function was. That wasn't drawn in for you on this one, and sometimes having a table just helps you a little bit. So I've done that, over here. So it's up to you how you want to look at that. But I also wrote out, this is the more expanded version of the parent function. So this is vertex form. So you can look at how things shifted. So my new vertex, if I look on here, so with parabolas, it's kind of nice because you do have a little standard thing. Absolute value, they all have like a key point scenario that you can plug in, but this one here is the vertex, so that would be on the new function or the transformed curve here is 1, -2, and so that is my h and my k. So I can go ahead and fill those in. F of x equals a x minus 1 squared plus k is -2. Okay, so one thing to think about too is you could have done it this way, a couple of different approaches. You could have said, well, I know my vertex started at the x equals 0 and it shifted right 1, so everything has to be written as opposite for the x, whatever affects x, because what would happen to get this back to be its original. Okay, so we would want to write -1 in there, and then the original being 0. And then I can also see that I've shifted downward 2 units, my vertex. Okay, that was originally 0, 0, and now it's at the 1, -2. So I know I had a vertical shift down of negative or -2. Okay, so we can write these things out as well, and that's helpful. So we had a vertical shift down 2 units. We had a horizontal shift right 1 unit. We also have a reflect. Now reflects can kind of go wherever you need them to go. But when we're trying to write the equation, we almost work in the reverse order of when we're actually identifying transformations, if that makes sense. Or following transformations, because we're trying to undo it and get back to what this equation is and write it out. So we have a reflection over the x-axis. So that means all the y's, which is going to be notated here, all the f of x's, which we can make that a be negative. So we know that's going to be a negative. We don't actually know the value of it yet, but we can figure that out. But we know that it should come out to be negative. So we have some things to work with, but where we're stuck is this stretch or compress. It's a little bit hard to tell. I probably could list out some points and do all that, but just to show you, you can pick a point, any point on your graph. So I could pick this one here. I could pick 3, -4, and I can plug that in to this function here. So I would do -4 would be my f of x, and then a I don't know, that's what I'm trying to find. X is, I said, was going to be 3. Then I have my -1. So it's important that you have the vertex in there. and then minus 2 for my k. And then this 3 minus 2 we can calculate that out. That's 2. So now I can solve this out for a. Negative 4 equals a, and 2 squared would be 4. So that's going to be 4a. Minus 2, add 2 to both sides. I would have negative 2 equals 4a. Divide by negative 2. And then I end up getting a. I'm sorry, negative 4. I want. And then I would get a is going to be negative 1/2. And that makes sense. I knew I needed to have a negative. So that works. Then I just have to take that a and put it back up into my function. So my answer over here, it's actually a g function, g of x. And then I would have negative 1/2 or negative 0.5. I think either was fine for this problem. And then x, you got to put back your original, generic there. X minus 1 squared. And then minus 2. And that is the answer. Hope that helps. Have a great day.